Hello, brothers, and welcome to this explainer. I'm here today to walk you through a critical standard operating procedure briefing. We're talking about what happens when our control systems and online sensors go completely blind. You know as well as I do, as wastewater operators and plant managers, our automated systems are literally the central nervous system of our facilities. When they fail, well, it's on us to step in immediately. So let's take our time today and really wrap our heads around this threat. Our standard operating procedure for this incident covers three distinct steps. First, we've got the incident name and definition. Second, the severity and impact scope. And finally, the detailed detection symptoms. Let's dive right in. Starting off with Section 1, Incident Name and Definition. So, brothers, technically speaking, we call this an instrument failure or sensor drift. Basically, it's the nightmare scenario where your SCADA systems, your PLCs, and those critical online sensors, your dissolved oxygen, pH, ORP, mixed liquor, suspended solids, and flow meters, they all start losing signal or drifting out of calibration. This directly causes our automated systems to lose real-time signals, which means your plant is suddenly operating entirely in the dark. And honestly, this is exactly why we can't just rely on theoretical baselines or textbook answers. During a failure like this, you're going to see a massive disconnect between what is actually physically happening in those tanks and what your control panels are telling you. Your field sensors are your eyes out there. When they drift, your digital eyes are lying straight to your face.
Moving on to Section 2, Severity and Impact Scope.
Make no mistake, this is a Level 1 critical event. It earns that absolute highest severity rating because it completely paralyzes our automation. When SCADA goes down, it forces you to operate these super complex biological and chemical processes totally manually. And let's be real, hand operating a plant under stress? That significantly bumps up the chance of human error, which then leads right to a very high risk of environmental discharge violations. Just take a look at these massive clarifiers and aeration basins. We all know these aren't just static pools of water, right? They are dynamic, living ecosystems. Without real-time control, your system just can't auto-adjust the blowers or those return-activated sludge valves based on the actual biological load hitting the basins. It's like you're suddenly flying a massive commercial jet, completely blind. Now, the really crucial point here is how this kind of failure multiplies. It spreads like wildfire. Just one bad sensor can trigger a massive cascade logic failure across your whole network. If the PLC thinks the water is too acidic just because of one bogus reading, boom, you've got severe chemical overdoses on your hands. Plus, when the system drops offline, we suffer a total loss of the historical data we desperately need for environmental reporting and, proving our compliance to the authorities. That danger physically lives right here, right at your chemical storage tanks and dosing racks. Think about it. If your pH sensors are feeding fake data to the PLC, your acid or base dosing pumps might just run constantly. And not only does that waste thousands of dollars, but it's going to directly kill off the fragile microbes in our biological treatment tanks. You also run the huge risk of missing critical process upsets entirely. Look at the sheer complexity of this piping and flow infrastructure. With lost signals, an extreme pH drop, or dangerously low dissolved oxygen levels can pass right through this maze of pipes totally unnoticed. Why? Because the lost signals prevent us from catching the violations in the flow until it is way too late and it's already hitting the outfall. All right, let's get into Section 3, Detailed Detection Symptoms. Your absolute first lines of defense are your control interfaces. If your SCADA screen freezes or just hangs up entirely, well, you've got a major problem on your hands. Furthermore, if you see a continuous red bad quality tag popping up on the panel or solid red indicators for sensor faults and comms errors, you are looking at a massive communication breakdown between your sensors and the PLC. Listen, brothers, when you're sitting at these control room interfaces, you've got to constantly be scanning your screens for these solid red fault lights. They are your earliest warning sign of a system disconnect. And the second you spot them, it is time to crack open those manual reference guides and gear up for immediate manual intervention. Digging a little deeper into the data, you really need to pay close attention if your sensor values just flatline. If those numbers stand completely still for a long time, especially when there are obvious physical process changes happening, that sensor is dead. Likewise, keep an eye out for readings that suddenly jump way beyond physical limits to show overrange, which means greater than 20 milliamps, or underrange, where they drop below 4 milliamps on your current loop.
You're also going to catch this failure by trusting your manual lab work over the automation. If you ever notice a massive, unexplainable gap between the online readings coming from these field sensor probes and the physical lab analysis you just pulled from those exact same sampling channels, your calibration has drifted dangerously. Always trust the lab and always question the sensor. Okay, now let's talk about what you're actually going to physically see and hear when you're out on the floor. You might be walking by and hear your chemical dosing pumps operating continuously without a single pause. Or on the flip side, freezing up entirely when they absolutely should be running. You might also hear your massive aeration blowers maxing out at full speed or just stopping dead in their tracks, all because they are no longer adjusting to the actual dissolved oxygen load in the water. When we're looking at this heavy mechanical equipment, your blowers and your motorized valves, these guys are the muscles of the plant. If your motorized control valves on this equipment simply do not respond physically when you send an open or close command from the SCADA room, that logic link is officially broken. The brain is no longer talking to the muscle. Let me just reiterate that. If valves fail to respond to commands out in the field or from SCADA, you need to take immediate action. Finally, look really closely at your return-activated sludge, or RAS. If your RAS flow stays abnormally fixed because the mixed liquor suspended solid signal is dead, you are rapidly losing control of your biomass inventory, and that is bad news.
These active aeration basins and sludge return systems rely completely on accurate, minute-by-minute, real-time data to do their jobs. If you're blindly returning sludge without knowing the actual MLSS concentration, you risk literally suffocating the biological heart of the whole plant.
When you step back and look across the general infrastructure of our plant, at these massive concrete basins, you have to realize that our safety margin is razor thin. Every single minute you operate under these blinded conditions with drifted calibrations, the danger to the entire treatment process escalates exponentially. It's a race against the clock. Our job, brothers, as we walk these decks and monitor these biological treatment basins, is to memorize every single one of these 9 symptoms. We have to spot these discrepancies immediately, whether it's a frozen screen in the control room or a roaring blower out on the floor, before the broken automation forces a catastrophic plant failure and a serious permit violation.
So I'll leave you with this final vital question to think about before you clock in for your next rotation. Are you truly prepared to spot these exact symptoms on your next shift before your control system goes completely blind? Stay alert out there, trust your training, and remember, never rely purely on a computer screen. If your gut is telling you something in the plant is wrong, thanks for tuning into this Explainer Brothers. Stay safe.